Well, hello, Mr. Schwannekamp again. Today we are starting our second unit. This is solving systems. Okay, so this chapter is all about solving systems. When we talk about systems, it's just a fancy way of saying that there's more than one equation. All right, so we're going to do this in a lot of different ways. You did this in Algebra 1 probably, but we're going to review it again. Today we're doing the easiest version. Today we're solving a system by graphs, so we're doing it graphically. So what's going to happen here today is we're going to get two separate equations, and then we're going to graph those two equations and see wherever they cross. Because wherever they cross here, so we've got two equations, x minus 1, or x minus y equals 1, and 2x plus y equals 5. We graph those two lines. And what we're going to do is find the one dot where they cross. They could cross once, they could cross no times, or they could cross everywhere. And we'll explain that here in a little bit. But we get one value, 2 and 1. And so what happens is this is the solution to this system. Or in other words, if I plugged 2 for x and 1 for y, oh yeah, that gets me 5. If I plug in 2 for x and 1 for y on that equation, it gets me 1. It is the only two numbers for x and y that is going to make that statement true. Okay, so that's what we're doing. We have two equations, and we're going to find the one set of numbers, x and y, that is going to make the statement true. So there's not really a lot to show you today. I'm going to show you and graph a few, but to be honest, it's exactly the same thing we did last chapter. 2/7 x minus 4. So I'm going to go to negative 4. My slope is 2/7, so my slope is up 2 over 7. Up 2 over 7. The one thing you do want to do today is draw as straight of line as possible. And so you don't want to kind of just guess here. You want to make this 1, 2, 3, 4, 5, 6, 7. You want to draw it as straight as possible. So like if you had a ruler or some sort of straight edge cell phone, something like that, we want to draw that as straight as possible because the whole goal is to find out exactly where this thing crosses. And so even that line right there that I just drew, it's not perfect. I would want to make sure that I could get as close to the dots as possible. We're okay. Hopefully we cross at one of these three dots because that's the easiest place to tell. All right, then we're going to graph the other one. X minus 9, so I'm going to start down here at negative 9. And then my slope is 1, so I'm going to go up 1, over 1, 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 up 1, over 1. Yay, there we go. Cool, we crossed right here. So I could draw my line, connect the dots, but I crossed them at one specific spot, and it was that spot right there. That spot is at 7, negative 2. Yeah, I got to turn off my line drawing stuff. 7, negative 2. That is the solution to this problem. If I plugged in 7 for x on this first equation, I would get negative 2. If I plugged in 7 on that second equation, I would also get negative 2. That is the only two numbers that is going to make that statement true. Let's try it again. 3/7 x minus 2. So we're starting down here at negative 2. Some weird slopes, but 3/7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And then 7. Boom, right there. Let's connect the dots. Yeah, I'm underneath it a little bit. It's hard to draw on here. There we go. And then we're graphing the second one. Negative 1/7 minus 6. So I'm going to start down here at negative 6. Down 1 over 7. So right there. Boom. Connect the dots. There's my line. All we care about is this spot right there. That is the one spot they cross. It is at negative 7, negative 5. So turn that off. Negative 7, negative 5. That is the solution to this problem. Those are the only two numbers I can plug in for x and y that would make this statement true. Easy. It's no different than what we did on the front side. Don't let it be any different. Oh, had a little bit of a formatting issue here. Sorry. Those go over there. Let's graph this. 4/3 x plus 5 is plus 5. 4/3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Boom. A line right there. 4/3 x plus 6. Here, here, here. All right. So when are those two lines going to cross? Those two lines, think back to your geometry days, but those two lines right there are parallel. They are parallel. Parallel means they have the exact same slope. And if two lines have the same slope, they are never going to cross. So if you have two lines with the same slope, and in this case have different y-intercepts, then they are never going to cross. And so the answer to this question right here, when are these things going to cross? They are not going to cross. And so our answer is no solution. There is no number that is going to make this statement true. There's nothing you could plug in for x and y into both equations that is going to make that statement true. So if you have two lines that have the same slope that are parallel, we have no solution. Let's try number 4. When I saved it, this 4 got messed up a little bit, but what's fine. Y equals x plus 2. So I'm going to start at positive 2. Up 1 over 1, up 1 over 1, up 1 over 1. There is that slope right there. Not perfect, but we did our best. And then we're going to graph this one. Well, I don't really want to graph it like this. I'm going to get y by itself just because it's always easier to graph y by itself. So I'm going to add 2x. Add 2x. So 2y equals 2x plus 4. Get y by itself. So divide by 2, divide by 2, divide by 2. Y equals x plus 2. So let's graph that. Y equals x plus 2. So I'm going to start here at 2. Uh-oh. And my slope is 1, so I'm up 1 over 1, up 1 over 1. It's the exact same line. It looked different, okay, because this one right here was already solved, but when we solved this other one, it ended up being the exact same line. So not only were the slopes the same, their y-intercepts were the same as well. And when that happens, it's two lines on top of each other. So what does that mean? Well, it means that there's a whole lot of numbers I can plug in. So look how many times it crosses. Like right here it crosses. Well, that's the ordered pair 0, 2. So what happens if I plug in 0, 2? Well, if I plug in 0 here, oh yeah, I would get 2 there. 0, 2 works for the first one. What if I plugged in 0 and... Oh yeah, if I plug in 0, 2 for that second one, it works for that one. So 0, 2 is a solution. Well, what about this ordered pair? Right there, that's the ordered pair 2, 4. If I plugged in 2, I would get 4. Yep, that would work. If I plugged in 2, I would get 4. Okay, that would work. In fact, any combination on these two lines, anywhere on this thing, if I plug it into one equation, it's going to work in the other one as well. So there's not just one solution. There's millions of solutions. In fact, that line goes on forever and ever and ever. So what we're going to say is there are infinitely many solutions, meaning there's no limit on how many answers we have. We could keep following that line forever and have all of those solutions work. Infinite, that is the infinity sign. Oh, I'm not a good English teacher. I struggle with spelling. Infinitely many solutions. You can do a little 8 on its side when you type it in. Infinitely is the best way to do that. Many solutions as well. Okay, that's it. Just do some different things. I'll do one more with you just to look at it. But this shouldn't be too crazy for you. X plus y equals 9. If I'm going to graph that, I want to get y by itself. So I'm going to subtract x. So y equals negative x plus 9. Let's graph it. Start at 9. Down 1 over 1. Down 1 over 1. Always run into the right. Boom. There's my first line. The second one, subtract 3x. Subtract 3x. Negative y equals negative 3x minus 5. multiply everything by a -1 to get rid of that negative sign. So it's going to be y equals 3x plus 5. If I graph that, I'm starting at +5. You got a slope of 3. 1, 2, 3 over 1. Boom. I found the spot. This spot right here is what I was looking for. It is at the ordered pair 1, 8. If I plugged in 1 to that first equation, 1 and 8, I would get 9. And if I plugged in 1 here, it'd be 3 minus 8. Yep, that would get me -5. I always like to double check in the end, but those are my solutions. Not too bad. Graphing to solve systems of equations. Remember, systems just means you have more than one equations. We're looking for ordered pairs, x's and y's, that are going to make it true. Remember, if you have parallel slopes, those lines are not going to cross, so it's no solution. And if you happen to have the exact same line, it's going to be infinitely many solutions. Hope that helps.